All right, hi, and welcome everyone to another exciting episode of our STEM Girls Virtual Space on mathematics. And this is the sixth episode of the STEM Girls Virtual class on math, and today we'll be discussing about geometrics. And I know it's a topic every one of us will be as a young girl, as a child in school who has been experiencing a lot of challenges on maths, you had a fear for maths, will be waiting for this opportunity. And here we have it as we are opportune to have um, a mathematician in the midst here who is going to be our teacher today. So please, girls, and everyone connecting out there, young people who are ready to learn, just endeavor to feel free and ask your questions and be rest assured that our teacher is going to give you all the answers you need. Yes. So um, while we proceed, I'm going to do a brief intro of our teacher. So you just have to get a clue of who she is and feel free to interact with her. So just give me a minute to share my screen.
I can't hear you.
Hello, can you hear me?
Yes.
All right. So I said just give me a minute to share my screen. Please, can you permit me to share screen?
Yeah.
Not you. I'm talking about the intern.
You can continue now.
Have been disabled from sharing screen. Participants has been disabled from sharing screen.
All right. You can't share screen yet. Can I go on?
You've been made a co-host, Tina.
Still not coming up, but let me see. Okay, I can see that now. All right. All right. I don't know. Can you see my screen? Please, if you can just confirm that. Let's see.
No.
Let's see. That's done. Okay, so we'll just proceed. Just proceed. So I don't know what's going on with this. I'm unable to share. Okay, so I will just read from here. So we just continue with that. Okay, so Anoluwapo Olawole is the name of our speaker for today, and she's a mathematician. She's an educator and a pioneer of N Flyer Academy. Our priority is to ensure that young people become successful in all they do, and her responsibilities is cut across helping young people groom their inanimate, inanimate skills and ensure that all difficult aspects are broken down to understandable pieces. Now, with Emmy Flyer Academy, she's raising an ideal child, which is possible. Um, she's also for us, which is also for us on constructive criticism and emphasis, making learning environment fun, and then also providing assistance to those whose learning abilities are special. Currently, Flyer Academy runs online and physical tutorials to help learners meet up with their academic goals. Um, with our support with Age Network, STEM Girls here, we're going to be providing you, making mathematics simplified for us all so that you don't have issues as a girl, as a boy, and then as young adolescents out there. So we'll be proceeding to the class proper. So over to you, ma'am.
All right, thank you so
Hello.
much. Thank you for
Thank
having
you.
me. As earlier
You're
said,
welcome.
my name is Anurag Bolawale. I'm an educator. Yeah. A lot of
Yeah.
people call me mommy for the kids, like the children.
Yeah.
All right, today we are going to just delve right into it. I want to thank you for the opportunity given to me. I want to thank all the young minds out there that made it to this meeting. Actually, it's a privilege. It's a privilege. When I'm somewhere, I'm here for a meeting and there's no audience. Definitely, I'm wasting my time. I want to appreciate this house
That's
for
true.
your support and for having me. Yeah, like I said, nobody is an island. So I'm just going to delve right into it. The topic before us today is geometry. And we are going to be looking at the introductory part of geometry. Some part of geometry in your early years in secondary school, maybe in the junior school or primary school. This is me going back to the basics of geometry, and I will be liking to share my screen soon. I was
All
able
right.
to put up together some little slides, though I've
Okay.
not downloaded the slide yet.
It's
Um,
fine.
Most of the time I work on my slides while teaching, so that at the end of the day I can download everything. I can incorporate what we did in class with this slide. Then
Okay.
maybe later we can now go back to it. We can now
Yeah,
go back to
sure.
it. Then I'll now download after we are done infusing what we have been taught in class. All right,
Okay.
so geometry. What is geometry? Let me try and share my screen. Oh, host disabled participant sharing screen. Wow.
Mm. I'll
Okay.
just give a minute. We're gonna try to fix that.
Let me just read from here. Don't worry, it's not a problem. All right. Geometry. Geometry is the study of shapes, sizes, positions, angle, and properties of shapes. Of shape. I will need the screen sharing later. All right. Geometry is the study of shapes, sizes, positions, angles, and properties. Now, why is geometry important? Geometry helps us to develop spatial reasoning, critical thinking, and problem-solving skills. Now, geometry is not the normal math where you have to say x plus something. Geometry actually has some guiding rules, and those rules will help you. They are very interrelated. So when you have a question on geometry, you will have to look critically at the figure before you and make sure that think. Come to think of it, you have done something like three classes ago, you have a new topic, and you have to link what you have done 3 classes ago to the one of 2 weeks ago to the one of today's class. That means you have to really retain knowledge. And the good news is that it's very easy to work on geometry. It's very easy because once you see the rule, you prove the rule, you test the rules, then subsequently you can work with it. Please, I need this. Is this fixed already? It's still not fixed though. I need.
Go ahead, you can now. You can share that now. It's been fixed.
Okay. Now this is geometry here. All right, that was what I just went into. And we said that geometry, real-world application of geometry. Geometry is used in architecture. You can see some buildings, they are different from the norm, though we are still developing in Nigeria. So we might not really have most of such beautiful structures. But then we see some structures like the structure of the mosque, and the top of the structure is looking like an arc. So that is application of geometry. We use it in engineering, we use it in art, we use it in design. How many of you know that most of the time when you want to draw a human being in art, you don't just start drawing. Some people, they start by drawing circles. They infuse, especially when you want to draw the eye, you have your circle being drawn, they put triangle, then with that, for example, sorry, let me correct my pen. All right, let me just, maybe so that I can understand. For artists now, they can have something like this. They want to draw the lip, then you see them connect this place here. Sorry, I'm not too good with this pen. And then they connect this place here, they connect this place. I'm not too good with this pen. Or maybe the mouth is tiny. All right. So let's say we have something like this.
Okay.
I thought I fixed a pen. So they will say from here to here, from here to here, then here to here, here to here. There's a way they will show address. I'm not much of an artist, but that is the basis of how they draw the lip. That's how they draw the lip in such a. So geometry is a very wide concept, and I would not like to assume that you are all experts, though I know that you are all young champs. I would like to go to the rudiment of geometry. So just permit me, yeah. Whiteboard is you. Sorry, that is loading. I'm trying to load my whiteboard, sorry. So there are some.
Okay.
Can you see this? Hello?
Yes.
Can you see
yes,
this?
we can.
Right.
Yes, we can.
So now there are some things I would like us to know when it comes to geometry. I said geometry is the study of shapes, lines, and so on and so forth. Now, we have different concepts of geometry. For example, we have when I say line, okay, when I say line, what comes to your mind when I say line? You probably think that, oh, is this straight thing? Or, yeah, line is always straight, but line in the actual sense is not just this. Line has an arrow, just like your number line. So line extends from here to here. Let's say, so this thing that I just draw now is a line. And it's not only straight lines that are called line. We can have a curved line, you can have a zigzag line, you can have different types of line, right? Now, this thing is called a line. It has a starting point and it has an ending point. In this in this kind of scenario now, it extend for this arrow to go like this. That means it can still extend backward, right? And it can still extend forward. It's not closed on this end. It's not closed on this end. If we look at this, if this is number line now, if we are to judge it, we can say that 2 less than x, which is less than 4, something like that. It looks something like this. So let's say we have a point C here. So this line that we have here can be called a line AB. You see that? A line AB. We can also call it a line, the line AC. Because even if it is here, the arrow still, when the arrow extends, it can still come and meet this B, and so on and so forth. Because it is not a closed property. Then we can also call this line CB. Now, it is different from this. If we have something like this, this is actually, it's also a line, but it's actually not a line. If you have this one like this one acts a fixed starting point. A fixed starting point. And this one extends to this other side. Let's say we have B, and let's say we have C. This thing is called a ray. It is called a ray. So, meaning that I can say this is my line AC. You see that the difference between the two arrows? And I can say this is my line CM. I can't say this is my line CB. Okay. Okay, I can say this is my line AB. But I can't say this is my line BC, or it's not correct. Because this thing has given us an idea that the starting point must always be here. For this one, the starting point is not defined. It can still extend to the back. I don't know if you are getting me. And this one can still extend to the front. Now, there's another thing like this. This is this one that has fixed starting point and fixed end point is called a segment. Do you get that?
Yes.
If this is A and this is B, if you have another point C here, you can only call this, the whole of this line segment AB. You can't call it segment AC. It's wrong. And you can't call it segment CB. It is very wrong. I don't know if you have gotten that concept. Yes. Now, the next thing you might want to, I don't know, if you have any question, you can just drop it in the chat box, or you can raise your hand and answer the questions. All right, so let me just delete this. All right. Should I delete it? I don't know if people have written it, but let me just display it for a while. All right. Now, we now have something called angles. Angles. An angle is the combination of two or more rays. Don't forget, this is what we call rays. It has a starting point and is going towards this side. Actually, here too, we can call this line CA. I'm talking about the line now. CA. Since it can go forward and backward. Here too, you can call this one line BA. Did you notice the change of the sign? So if you want to call this,
sorry, I don't know if okay.
I'm on this ray, right? Yes. I'm saying that there's another thing I forgot to mention. You know that there is concept of vector quantity and scalar quantity. The scalar quantity is a quantity that only has magnitude. What is magnitude? It is size, maybe 2 centimeters, 2 kg. So it has a magnitude, it has a quantity, right? But it does not have direction, 2 centimeters. But for a vector quantity, it has both magnitude, it has both sides, and it has direction. For example, when you are doing bearing and distance, you can say a man walks 2 centimeters north, right? That has a direction. You cannot now say 2 centimeter. You know, this is the you see that even if you observe the compass, okay, right? So if I say draw 2 centimeter knots, you cannot draw this and tell me that this is 2 centimeter knots. It is wrong. 2 centimeter knot has to be like this, going to the knot position, and you cannot say this is 2 centimeter. Do you get that? Is that understandable?
Yes.
Now, if you
Yes.
look at this ray now, if you look at this line here, you can go forward and backward. It's still the same magnitude and direction. The direction is not really defined. It can go backward, it can go forward. But if you look at this, it's only going forward. Is that gotten?
That's
Now,
true.
I call this one line A, B. So if I want to change the position of BA, I can say line, sorry, I picked the highlighter. Okay? You can call it line BA. Just that the arrow will have to go backwards. Is that gotten? That means
Yes.
this place is the starting point. Then, do you get that? All right, so
Yes.
there is something I want to mention now, and that is angles. Angles. Now, an angle is a combination of 2 or more rays. An angle is a combination of 2 or more rays. Okay, sorry about that. Let me just delete. Okay. So we have angles. A combination. Can you see my handwriting, please?
Yes.
Or rays. Because most of the time when we are drawing, right? I know that in our junior secondary school, we've been introduced to constructions. And most of the time when we are drawing, we will say this is our starting point. We will say line A, B. Yes, you now pick your compass and start drawing, right? You now say, this is your, okay, oh, sorry. Oh, that my hand is not that straight. Let's just try. You now say, this is your, it's not straight. Oh, oh my God.
Maybe we
Let's
could
try.
start it.
You now say, maybe this is your A, B, C, right? There is a direction, meaning you are moving from here to this point, right? When you are drawing, from here to this point, when you are drawing. All right.
Yes.
So, an angle is combination of 2 or more rays. When you have this and you have this, you call this place, maybe you call this place 40 degrees, right? And you call this place your line. Let me call it A, B, right? You will see that when you want to draw, if you started your compass from here, this will be your fixed point where it's starting. Now, do you get the explanation of ray better now? You will put your compass, if you started with your your compass here, this is the point where you will start drawing every other line that is attached to this particular angle, right?
Yes.
So this is called an angle. Okay. Two or more rays. So now there's something I also want to mention. We have midpoint. We have midpoint. A midpoint, let's say you have a segment AB. A segment is the one without any direction. Now, if this is a midpoint, that means, let's say if this is the midpoint, let's say this is the midpoint. What that means is that AC is equal to BC. Meaning if this whole line was supposed to be 40, this place will be 20, and this place will be 20 centimeters. That is the midpoint, right? Now,
Yes.
I also want to mention what we call the bisector. Like I said, today is an introductory class. we are going to go through all that is associated with geometry, the basics, then before we can build on it. You know, if you don't know the basics, there's no way you can build on it. So let's look at a bisector. A bisector is a line or a ray that divides an angle into two equal parts. So when they say bisect an angle, it also means that you should divide it into two equal parts. Now, I want to clear the screen. I don't know if you have jotted what you want to clear. All right, so now most of the time we don't know that a line or a segment or a ray is also an angle, even if it is straight. This is also an angle, but it's its angle on a straight line. An angle on a straight line equals 180 degrees. So for it to be equal to 180 degrees, that means it's also an angle. Now, let's say that I'm tired of using A and B so that people will not think it's only A and B. Let's say this is point Q and a P, and this is point Q. A bisector, let's say this is the midpoint. Oh, okay, let's say I'm not too. That means I will have to clean. Let me just clean. Okay, let's say this line goes through here and divides it, for example, to two equal parts. And divides it, for example, to two equal parts, P and Q. If this part is equal to this part, it's called a bisector. But in most of the cases, the bisector of a straight line, don't forget that. So the difference between the bisector of a line and the bisector of an angle is this. Please let's listen. For that of a straight line, it divides the line into two equal parts. This is obviously not equal. So let me adjust my drawing. So let's say this place was 20, PQ was 20, right? So if this place, if after this has passed through the midpoint, it divides these two lines into 10, 10. Then we say that ray RM, look at that. I said ray because it's starting from here, sorry. It's a fixed point here and it's ending here. That makes it ray, a ray. Then ray RM is a bisector of segment PQ. That's bisector of a line. We are looking at it from the perspective of it being a line. Let's now look at it from the perspective of it being an angle. You know, this will be angle 180. So if there is this line that passes through this middle and divides this angle into 90 degree, 90 degree. Let's say this is K, this is M. Now we can say ray P K MK is a bisector of angle. You see it now. And if you want to write your angle, this place, let's say this is M. So we put the one with where the degree is, where the value of the angle is. will be in the middle. PMQ. Do you see that? It was 180 degrees. So this implies that angle PMK is now the same, is equal to angle. And I told you that this middle one is the owner of the angle, right? So it's now equal to angle QMK. Now, let's explain that on a different type of angle so that you will get it properly. This is an angle on a straight line. Let's work out our bisector on another angle, say angle 60, angle 40, and any other angle. So I'd like to clear this too. I'd like to clear this. All right. So let's say we have this line. Sorry. Segment. This is a segment. And it cannot be fixed there. It can extend with the combination of two rays. So let's say this is 50 degrees and this is A, B, C. So our angle, I said if you want to write this now, we'll say angle CAB. You can write it like this. Put your angle on the one in the middle, or you say angle, put it by the side. ACB. Anyone will be right. Is equal to 50 degrees. Let's now assume that a ray passes through it that divides it into two. Let's call this place M. And it makes this place become 25 degrees and this place become 25 degrees. So we say ray AM is a bisector of angle CAD. I don't know if we got that concept. Did we get that concept? Now,
Yes, ma'am.
okay, so we can move on to parallel lines. What are parallel lines? Parallel lines are lines that are drawn, or let me say ray. It can be line, it can be ray, it can be segment. That their paths can never cross each other. Their paths can never cross each other. I know because I'm using a writing tab and my hand is not straight. It is possible for this one to want to cross. But let's say this is a ray and this is another ray, right? Let's say this is ray A and this is ray P Q. The fact that no matter how long you extend these two lines, they can never meet, they are parallel. We say ray AB, look at this sign, it's called parallel. Parallel. It's parallel to ray P, right? You are going through the basics.
Yes.
Anything you have missed in your junior school, you are catching up. So don't worry, Miss Martina already said we are going to repeat this class. All right, so
yes.
Let's go to perpendicular. And yeah, I must mention that it's not only when they are straight, okay, straight in the sense of straight, but it's not only when they are heading east together, right?
Yeah.
Not only when they are heading east together, they can be parallel like this, provided they will not meet, no matter how long they extend it. So if this is CD and this is EF, so that somebody will not say, it's not parallel since it's not going towards this direction. Do you get that? So
yes.
Once, no matter the direction, once they can never meet, they are said to be parallel. So CD is also parallel to ray F. Now let's go to perpendicular. Perpendicular angles or lines are lines that meet at 90 degrees or right angle. I believe we are used to the terminology. Now, if you have this straight line segment, let me use a segment this time around. let's say MN, and you now have these other segments. These other segments, let's say this is now CD. Once they meet as 90
Oh, so sorry, our teacher got disconnected. But just hold on. Give some minutes. She'll be joining back. If you have any.
Hello.
Hello, ma'am.
Yeah. Welcome back.
Sorry, it's network that disconnected.
Okay. I even thought it was my mobile connection. Fine.
Ma'am?
I said I even thought my mobile data was exhausted.
Oh, okay. So we can continue.
All right. No problem. The screen sharing has been disabled again.
Ma'am?
The screen sharing has been disabled.
Oh. So sorry, my network is very bad.
I just have 3 more concepts. Okay, 4 more concepts to do and I'm done. Because this will actually give the basis for working on any algebraic I said algebraic geometric question. I just have 3 more concepts to do and I'm done. So can I continue now? Hello?
You can continue, ma. You can continue.
All right, so I'm going to be sharing my whiteboard. All right, I have to still loading. All right. I said this means that CD, segment CD is perpendicular, that's it, to segment MN. It has erased some of the information. If the two segments meet at 90 degrees. We can still extend down, it does not matter. Can extend down something like this. Doesn't matter. Now, let's look at sum of angle in a triangle, the complementary angle, the supplementary angle, the vertical angle, and the alternate angle. Now, the sum of angle in a triangle is 180 degrees. So let's say we have this. Please don't mind my drawing once again. So how will we know that it's a right angle triangle is the presence of this box, which means 90 degrees. Now, I want to use it to explain the concept. Okay, let me explain this. So if this is A, B, C, that means angle A is equal to, plus angle B plus angle C must be equal to 180 degrees. Let's say you have angle. Let's now imagine this is, let's assume this is small letter B, small letter A, small letter. So we can say A plus B plus C is equal to 180. Now that leads us to complementary angle. So let's assume that this is a right angle triangle A, B, C, and this place is already right angle, right? If this place is 20 degrees, since we know that A plus B plus C is equal to 180 degrees, and our A is already 90 degrees, our B is 20 degrees, then what is our C going to be? That will be 110 plus C is equal to 180 degrees. Therefore, angle C will be 180 degrees minus 110, and that will be 70 degrees. So that means angle C is 70 degrees. So if we look at angle B plus angle C, we will discover that the sum is going to give us 90 degrees. Sorry, that was not supposed to be there. So we can say that angle B and C are complementary angles. They are complementary angles because angle B plus angle C is equal to 90 degrees. So complementary angles are angles that add together to give 90 degrees or that sum up to 90 degrees. I hope that is clear. Now let's go to supplementary angles. Supplementary angles. So supplementary let me know. Okay. Supplementary angles are angles that sum up to 180 degrees. So if you have something like this, actually it is simple. Let's say you have A, B, and you have, let's say, C here. If you are looking for this degree C, right? Let's say we have 80 80 here. Angle C, okay, let me name this M. So angle ACM will be 180 degree minus 80 degree. That's because sum of angles on a straight line. So angles that sum up to 180 degree are supplementary angles. So the next one we have are vertical angles. Vertical angles. I want to make sure this is out here. I don't know. All right. I want to believe. Do we get this? Please let me know if you can hear me and you get this. Nobody's talking. Am I heard?
Yes.
Yes. Okay. Let's go to vertical angles and alternate angles. That's what we call it a day for today. Now, vertical angles. If you have something like this, I don't like it when my, so, okay. Okay. I want it to be a ray. Let's assume this is ray AB and this is ray CD. Now, if they form a times, this means that whatever angle is here is equal to the angle that is here. And whatever angle is here is also equal to whatever angle. Now, practical solution. A practical solution. All right. Let's say this is 20 degrees. Since AB is a straight ray, that means the sum of angles on AB is 180 degree, right?
Yes.
Right?
Yes,
So,
ma'am.
this place is 20. This other place will be, what will you add to 20 to give you 180? That will be 160 degrees. Right?
Yes,
now,
ma'am.
if you look at this place too, this CD is a straight ray also, right? That means
Yes.
whatever is here, that means the sum of angle on this side. Okay, since this place is a straight ray too, that will be this place plus whatever is here, let's assume is X, must also be equal to 180 degrees. So that will now be 20 plus X is equal to 180 degrees. You will discover that your X will be 180 degrees minus 20 degrees, and that will still be 160 degrees. Do you see that this place is already equal to this place? Right?
Yes.
Now,
Yes,
let's take this place. Let's call this place Y. We want to see if it will be truly equal to this 20. Right? Now,
yes.
let's look at this. You know, this is a straight ray, AB, right? This is also
Yes.
AB. So this is ABD or something. So this will be Y plus 160 degrees will be 180 degrees. And Y will now be 180 degrees minus 160 degrees. And that will still give us 20. Is that gotten? Do you now see that the rule is true? So opposite angles on vertical lines are equal, or vertical angles are equal. So let me now, since you've gotten this, let me now draw a fresh line. So if this is a vertical angle, whatsoever angle is here is equal to, let's say, X, Y. So X is equal to Y, right? Let's say this is M N. So that means M degrees is also equals to 0. So they are called. So I want you to do me a favor. Anytime you are given a question like this and you get your answer, always give the reasons. Always give the reason. For example, if I say if you are given a question such as this place is 150 degree, they now say find x. You say x is equal to 150 degree. You now say in bracket because they are vertical angles. That's what. So you not just write vertical angles or so, and you not just write 150 degree and leave it like that. You now see where I said it will help your critical thinking. Imagine this is just drawn. It will make you refer to the rule that is already existing. All right, let me go to the very last one. Very last one. Then you can ask me questions and all. I don't know if they are permitted to ask questions or if I'm permitted to give them a little exercise.
Yes, you are. Yes, you are permitted.
All right, no problem. So let's clean this. Let's say when we have this kind of figure, right? It is called, or this kind of figure. It just looks like Z. It looks like Z. This angle, if it is Y and this angle is Z, the angle here is equal to the angle here. It is called alternate angles. So if this one is also P and this one is Q, P degree is also equal to Q degree. They are alternate angles. So same goes for the angle here. If the angle here outside here is M and the angle outside here, this circle, you know, the sum of angle on at a point is 360 degrees. So this angle here is N. That means N is equal to N. The reason is also alternate angle. And same goes for this one out here. Now, I've gotten to the end of this. I just want to solve some little exercise. I want to give us one that is all encompassing. Now, I don't know, in your junior school, you always see something like this. Sorry, I don't always like my line. But you see something like this. Now we can see three different things here. For here,
Yes.
let's say this place is 20, right? We want to fill up all the angles. This is what vertical angles, right? Vertical angles, right? That means this place will also be 20 degrees, right?
Yes.
Right? And this is angle
Yes,
on the
ma'am.
straight line. That means this place will be 160 degrees. That means this place will also be 160 degrees vertical angle. Right? Now look at this. You have something like Z here. Right? That means this place will be 20 degrees. Right? Since these ones are vertical angle, this place will also be 20 degrees. Then from here you can solve. This place is 160 degrees. This place is 160 degrees. Is that what it? Do you see that? It's so simple.
Yes.
Just one value was given and we are able to solve everything based on the rules. That's why I said it promotes critical thinking. Now, I've gotten to the end of this class. Let me just give you just 3 exercises to solve for me.
Okay, ma'am.
Number 1. Tell So for the A part, I have something like this. So for the B, I have I don't know if you can annotate. Can you write on my screen?
No, ma.
You can't. You don't have a gadget.
Yes.
Okay, no problem. So I need
I can actually write, but I think the kids can't do that since
okay, the kids
they're
can do
joining
that.
from a phone.
All right,
Yes.
can you just give me a name of one of the kids to answer this for me?
Okay. Introduce yourself, Jeremiah
All right, Jeremiah
and Mercy.
and
Miracle rather. Sorry, Miracle.
Miracle. All right,
Yes.
Ma.
Jeremiah, can you please tell me the answer of A?
Okay. Ray.
It's a ray. Very good. Snap for yourself. Snap for yourself. All right, that's beautiful. Miracle.
Ma.
For B, this is what?
Segment.
Very good. Snap for yourself. That's quite impressive. I love that. Snap, 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 snap. And the last one, I want our mistress to answer. Mistress
Okay.
Martina.
Okay, I'm with you.
So this one is a. Okay, there's somebody bearing Esther. Is the person a student or?
Yeah, I guess you can answer that.
All right. I don't know. Please, can you answer that for us, Ms. Esther? This C is a what? Not getting response.
No.
All right, Jeremiah, you just do that for us. It's a what? It's a what?
Line.
No, it's a
That's
ray.
part.
That's where it's a ray. It has a starting point. It's still a
Yes,
ray.
yes.
So it's a line
Yes,
when it's like this. So if this is Q, this is R. So this one is a line.
In line. Yeah.
Okay,
All
ma.
right.
Thank you.
All right. So let me ask one more under all these alternate angles and all. So I am drawing number 2. So don't let me put A here. Let me just erase this A. So I have this is angle M, and we were told that this one is angle 60 degrees. So find angle M. For this one, so you see this place here is X. So we are told to find our X and our B here. If this place is 120, this place is B, this place is 45. So what will this place be? And the last one, vertical angle, corresponding angle. So let's say, okay, let me just write it in form of a word. If A and B are complementary angles and B is equal to 61 degrees, find A. Now, Miracle, what is M going to be?
M is going to be 60-degree alternate angle.
Yeah? M is what?
60-degree alternate angle.
Is that right? No, I did not say M here. My M was not here. This one will be 60 degrees. You tried though. Don't forget, this is angle at a point. So,
Yes.
and I said angle at a point is 360 degrees. This thing points angle at a point. It's from circle, right? When I
Yes.
had this other distance. So this should be M plus 60 degrees equal to 360 degrees. So M should be 360 degrees minus 60, and that should be
That is
what?
300 degrees.
Do you understand it now?
Yes, ma.
All right. Since this place is 180, 120, what will my B be? What will my B be?
Mom, coming.
Please solve that. Jeremiah, can you answer that for me? And Miracle will answer the X degree for me.
Answer it. Hey.
Okay, let me bring this out so that you understand. You can actually separate it. You see, this is your B here, and they told you this place is 120. So what will your B be? This looks like what?
Vertical angle X.
It looks like a vertical angle. But from here,
Yes.
let's say this is AB. This segment AB is what? What kind of line is it?
Parallel.
No,
Yes.
it's a
Ray. Oh, she said,
okay, even if you want to use vertical angles, if this place is 120 degrees, this place will be what?
60.
Yes, 60 degrees. And how did you get that? Sum of angle on a straight line. So that is sum of angles. That's good. On a straight line. On a straight line. I can't finish writing that. Okay, let me just clean this part because I want to use that remaining side to do something else. So we have established that that is 120, that is 60 degrees. So you can always separate your given figure. So they told us that this place is X degree and this place is 45 degrees. So what will our X be, Jeremiah? This is what kind of angle is this that forms Z?
Complementary.
No, Z. Did you jot down what I explained? Yes, alternate. So that means this way will be what?
It will be. But what do you say?
This place will be what? X. If this place is 45, this place will be what?
15. Okay.
No. If this place is 45, this is Z now. Something like this. So this place is 60, this place is 60. If this place is 45, this one is what? If you have gotten the answer, speak it out.
Okay, ma.
Is what?
I'm coming. 315.
Oh, you are mixing. You are already mixing up this concept.
Still 45.
Yeah, it should be 45. Did you get if it falls on the same? The reason
Line.
this one was minus is because it's not this one inside that they said we should look for, it's the one outside. Do you get?
Yes.
So since we know that the one inside must be 60, the one outside, we know that what is the relationship between this one and this one? They all, both of them, when you add them together, they give you 360 degrees because an angle at a point. Do you get that? So that is why we
Yes.
have to go this extra mile. But for this one, it is what is inside that they said we should look for. So it's 45 alternate angles. Is that gotten?
Yes.
Now, this last one. If A and B are complementary angles, what is the condition for complementary angles?
Oh my God. I'm not seeing the question.
If A if A and B are complementary, and B, they told you that your B is 61. So what will your A be?
Now I'm coming.
Okay.
Stop.
Waiting.
Just say something. Say something. Say something.
First of all, what are complementary angles?
She gave us down. Angles that sum up to 180.
No, that's supplementary. Complementary angles are angles that sum up to 90 degrees. Please kindly go through this. Well, it's posted on YouTube, right? So I guess they can go through that again. So when you add the two angles, they will give you 180 degrees. That's why they are called complementary.
Angles.
So
okay, Mike.
If
The answer
is equal to 61,
29 degrees. 29 degrees.
Have you gotten it?
Yes, ma. I said 29 degrees.
Oh, I didn't hear that. So 29 degrees. That's so beautiful. And with that, I've come to the end of this class from my hand. I don't know if you people have any questions for me.
Thank you, ma.
No questions.
Ma, please, can you?
Okay.
There's question,
I'm
ma.
all ears. Yes?
Ma, there's question. Okay, ma.
Okay.
Please, can you mention all the angle that we have in mathematics?
All the angles that we have in mathematics, like I said, no one is an island. But for the ones I mentioned today, I mentioned the complementary, the complementary, the supplementary, the vertical angle, the alternate angle, the perpendicular angle, the parallel angle. We have the bisector angle. We have the transitive angle, and so on and so forth. See, the list is unexhaustible. I know that there's even probably some angles that I myself have not encountered. Do you get that?
Okay, ma. Thank
you.
Ma.
What's most important is that they are interrelated. Is that gotten?
Okay.
Yeah. Do you understand that? Is there any other question?
Ma. No, ma.
Thank you so much for having me. With this, I'll just mute.
Thank you, ma.
I hope you learned something today.
Yes, very well, ma.
Thank you so much, ma. So, Miss Martina, I'm done, ma.
Okay, thank you very much, ma'am. I think for the lectures, I hope they all understood, and for those that will be connecting to watch later on YouTube, will also drop their questions. Do you have any question you've asked? Okay, so that's good. Thank you, and thank you everyone for connecting. So we'll see you same time next week, Friday. So yeah, bye. So we'll be doing the continuation phase of the geometric. So stay connected to learn more. Yeah, bye. Thank you, ma'am. Enjoy the rest of the day.
Yeah, you too. Thank you so much. It's a privilege. Bye.
Bye.